Welcome to the Northeastern University Cold Spray Simulation Tool. In this video, we're going to look at the main features of the website and how to run a simulation. To start, I'm going to log into my account, and I can do so right here. This allows me to save simulation data upon completion of a run. And I have the option to log out at any time, and notice that while not logged in to an account, I still have the option to make new runs. These runs will simply not be stored and will disappear upon navigation away from the results page. So because I want to be able to save the simulation I'm about to run, I'm going to log back into my account. And now that I'm logged in, let's navigate to the input parameters page, to this new simulation page right here. So here I can input all the spray parameters for the cold spray operation that I'd like to simulate. And note the image above the form, which specifies which inputs correspond to which locations of the spray or dimensions of the nozzle. So to start, I can select from a predefined list of common cold spray materials, or I can input custom material properties through this button right here. So for now, we will just select something like pure nickel right here. And next, we can enter the gas properties corresponding to stage 1 right here. So we have the chamber pressure, the chamber temperature, and the composition of nitrogen and helium in the spray. So we can do whatever we want. I'm just going to run a pure nitrogen spray, and we have the option to adjust the unit cost for nitrogen and helium right here in dollars per kilogram, but I will leave those alone for now. Up next is stage 2. This is all the powder information that we need to enter. So I'll start with the initial temperature of the powder as 20 degrees Celsius with an injection rate of 2 grams per minute into the flow, and a unit cost similar to the unit cost of nitrogen and helium based on the material being used. Now, up next, note that the underlying model accounts for particle shape and size distribution. So that's what these inputs control right here. I can enter a particle sphericity factor to account for the shape of the particles, and then I have these inputs for the particle size distribution right here. So these are cumulative distributions of particle sizes in your batch. So what I'm saying when I enter this is that 10% of the particles are smaller than 24 microns in diameter, 50% of the particles are smaller than 36 microns in diameter, and 90% of the particles are smaller than 50 microns in diameter. So now that we have that input, we can move on to the nozzle geometry. So right here I have a list of standard nozzles that are used in cold spray, or again, I have the option to input custom dimensions for my nozzle. But for now, I'll just leave it as this first option. And then I need to enter the inlet length and the standoff distance as well. Those correspond to sections 3 and sections 10 on the image above. So finally, right here, I have the option to select whether I want a substrate in my simulation or not. So if I check this right here, that means I am asking the simulation to account for a substrate at the end of my spray, to run the simulation as if there were a substrate there. And if I leave it unchecked, that means that the simulation will run as if there were nothing right here at the end of the spray, as if it were just free air for the particles and gas to continue flowing past. So I want that checked. I want a substrate in my simulation right now. And finally, I have the option to input a title right here for my run. So I will call this SimTest1. So it's easy to find later. I can go back and find it based on this name. And that is all the information that we need. So I will hit run right here. And now that begins the simulation. So it's running the simulation right now. And upon completion, I am redirected to the results page, which will come up in a second. So right here, it's redirected me to the results page. On the left-hand side, I have a list of all the spray properties that we input for the simulation. And these include things like the material properties, the nozzle geometry, the gas properties, and the particle size distribution. All that information if I want to revisit it and remind myself of what parameters we entered for the spray. And on the right-hand side right here, I have all of the output plots for this run. So the first plot displays the velocity and temperature profile of the gas and particles throughout the length of the nozzle and the standoff distance. And remember, we have a distribution of particle sizes. So This displays the data for the mean particle diameter. And note that this region of interest right here is the throat location. The nozzle throat location is what it corresponds to. And right here, we can see that this corresponds to the nozzle exit location, and then this would be the standoff distance right here, with the rightmost wall of the plot representing the substrate location. So we have more plots to select from right here. If I want to, I can go down to nozzle profile. This shows me a visualization of what the nozzle looks like on a plot. I have gas properties throughout the length of the flow as well. We have pressure, density, viscosity, and thermal conductivity. And these next two plots, particle velocity and particle temperature, show properties of the particles split up by particle size, particle diameter. So you can see right here we have separate plots for particles of 5 microns in diameter all the way down to particles of 80 microns in diameter. And you can see that also included on this plot is the gas velocity for reference and comparison to the particle velocities. So we have velocity right here and a similar plot for temperature right here, split up by particle size. Now next is the particle impact conditions plot. And you can see this shows the overall deposition efficiency of the spray as well. And on the plot itself, we have plotted the impact velocity by particle diameter, the critical velocity, so you can compare those for each particle diameter, and the impact temperature of each particle diameter. So the final two plots right here are the consumption rates and the costs. The consumption rates show just that, the consumption rates of gas, the powder, and the powder deposition rate as well. So how much of that powder that's being consumed is actually being deposited based on the deposition efficiency. And finally, the cost analysis right here. So how much of your cost came from gas consumption versus powder consumption, and then an overall cost based on these two factors. So that's a quick highlight of all the output plots returned from the simulation. And now let's take a look at how they're stored. So at the top of this results page, I have the option to delete this run, to start a new simulation, or to go to my run history. And this run history page is where I can access all of my previously run simulations and review the data for those. So following this link, I can see all the runs that I've made in the past, along with the new simulation I just ran, shown up here as SimTest1. Here, I can go back into any other run to view that information, or I can delete runs from here. So say I wanted to go back into this ID14 DE test right here. Notice I had custom nozzle and material properties for each of those. So if I come back into here, I can see all of this information that came along with the run, and I can go through and view all of the different plots for this run as well. And when I'm done, I can return to the run history and say I no longer needed that run if I was done with the data that I was using that for. If I wanted to clear up some space on here, I can simply hit this little X right here and delete the run permanently. So that will erase ID14, that DE test run that I had, and leave everything else behind. So if I wanted to start a new simulation from here, all I need to do is click on the New Run button on the nav bar, and I'm redirected back to the inputs page to enter in the new spray parameters for my new run. So with that, that was simply a brief review of the main features of the site and the simulation tool. Thank you for watching and enjoy.